Okay, so I'm going to recap what we did last lesson very quickly and go over some of the points that I asked you to look at on neutralization reactions. So last lesson, you watched a few videos of acids reacting with bases or alkalis, and you saw some practical applications where you looked at bee stings and wasp stings, and also you looked at an experiment where you had an acid mixing with a base to produce salt and water, and you had um, somebody explain quite nicely some acid base reactions. So, what I asked as an extension task was to look at the video and write down a symbol equation and then balance that symbol equation. So the first reaction that you saw in the video of that person explaining the reactions between acids and bases was calcium oxide reacting with hydrochloric acid and producing calcium, and the chlorine reacting with it to produce calcium chloride. So some of you still thinking that how do I know what to write down here as the salt that is produced? Now, from the alkali, the first element in the compound takes the bit that's attached to the hydrogen in the acid, which is chlorine in this scenario. So the first element, which is calcium, will take the bit that's attached to the hydrogen and it becomes calcium chloride. And the remainder is water. There's oxygen in calcium oxide, there's hydrogen in hydrochloric acid, and they combine to give us water. Now, I asked you as an extension task to write down this equation in symbols. Now, you can find every single one of these formula on the internet. So you have calcium oxide, hydrochloric acid, calcium chloride, and water. Out of these, I expect you to just know one. Eventually, over the years, you will get to kind of figure out how to write all these out without using the internet. Once you had written this out, then what I wanted you to do to balance the equation. So on the left-hand side, we have one calcium. On the right-hand side, we have one calcium. So that's pretty much balanced so far. Let's look at the next element, oxygen. On one on this side, we have one on this side. Okay, right, then let's look at the hydrogen. There's one here, but there are two here. So straight away, I'm thinking I need to double the hydrogen on this side. So I've put a 2 in front. Remember, I cannot put a 2 here because that will change the compound itself. So I'm just having multiples of that compound. So I put a 2 here. That means that the hydrogens have doubled, but also the chlorines have doubled as well because we've got two lots of hydrogen chlorides. Now let's have a look on the right hand side. The hydrogens now are balanced. That means that we have two chlorines on the left. Now we've got two chlorines on the right because we've got the Cl2 here. So they balance automatically. And now we've got a balanced equation. We've accounted for every element on left and right. Similarly, the second equation that you were shown was magnesium hydroxide, which is the alkali, reacting with the base, producing, again, the first part of the alkali, which is magnesium. And the here we haven't got hydro in the actual word, but in the symbol equation we can see the hydrogen, but the magnesium reacts with the sulfate here. Okay, so the bit that the hydrogen is attached to, that's what the magnesium reacts with and takes it. So we've got magnesium sulfate and water. So remember, every time there is an acid-base reaction, one of the products is always water and the other one is a salt. Okay, so here we have magnesium hydroxide plus sulfuric acid. Now on the left hand side we have one magnesium, right? We have one magnesium. We have a sulfate SO4 here. We've got the SO4 here as well. So that's been sorted. Now what we need to look at is a hydrogen, two hydrogens here. We've got two hydrogens here, so that's okay. We then come back to this bit here. That's oxygen, hydrogen, the hydroxide ion, but it's twice double. So we've got two hydrogens, two oxygens. So what we need is an extra two hydrogens and an extra two oxygens. So what we've got here is, by putting the two here, we have taken care of these two oxygens that are here. And by doubling the H2 as well, we have got four hydrogens. Two have been taken care of here, and then two over here. So we've got four hydrogens. Okay, that was a little tricky. If you're looking at this and thinking, wow, that was quite tricky, remember that in year 9, again, you will look at balancing equations, and then you will continue to look at balancing equations in various chemistry topics. So eventually you'll get better and better. Okay, so the last equation was sodium carbonate plus nitric acid giving sodium nitrate, water, and carbon dioxide. So here we've got your salt and water, but in addition, we've got this carbon dioxide because of this 8 at the end and this carbon as well. Okay, again, this will naturally you'll be able to pick this the more and more often you see these type of reactions. Now we have got sodium carbonate straight from the internet as a chemical formula, a nitric acid HNO3, sodium nitrate NaNO3, H2O as water, carbon dioxide CO2. Out of these I would expect you to know water and carbon dioxide. Now if we have a look at this, we've got two nitrogen, two sodiums here, and we have one sodium here. So automatically I put two there to make the two sodiums. But that has a knock-on effect of doubling the NO3 as well. Remember, all of this is doubled. So the NO3 has doubled. So there's an NO3 here, and I will have to put a 2 in front here, which will mean the NO3 will double as well. But that inadvertently doubles the hydrogen. So by doing that, now I've got two hydrogens on this side. I look at the water, I have the two hydrogens, so that is balanced. The oxygen, now we have to look at this CO3. We've got one carbon and three oxygens. So we've got the hydrogen sorted out. We've got 1, 2, 3 oxygens, that's sorted, and one carbon, and that's sorted as well. So we've balanced this equation. So I've done this relatively quickly, but I did sit and think about this, and I looked at every single element on either side, and I balanced them accordingly. And again, I said that you will go with this over and over many times, and eventually these will become easier and easier. This is an extension task, so if you're kind of thinking, okay, I kind of get it, that's okay. Bare minimum, I want you to start getting used to writing out the symbol equations. Okay, familiarize yourself with how these word equations look like in symbols. So the neutralization experiment that you were given and shown as a demonstration on that YouTube clip, you had an acid, hydrochloric acid. When we look at acids and add universal indicator to acids to identify what pH it is, just by looking at the color, we know that acids will have a pH of 1 to 6 on the pH scale. We mixed it with a base, which was sodium hydroxide, and that would have had a pH of somewhere in between 8 and 14. Now, when we added universal indicator to the acid, it turned red. We didn't add the universal indicator to the alkali in that demonstration, but if we did, it would have turned blue. Now, when we mix the two together and an equal strength of base added to an equal strength of acid, eventually what would happen is that color of that universal indicator would turn neutral. It will turn green. That indicates to us it's a pH 7. And as soon as that happens, as soon as we see that green color appear from the universal indicator that we put in, we know that we have neutralized the reaction. The acid has completely cancelled out the base to produce an overall pH of 7. Now, what's inside here? We have a salt and water. So salt and water is mixed in this solution now. So how do we separate salt from water? Now this is today's lesson. How do we separate salt from water? So what we are going to do, we're going to pour this salt water we have produced from the neutralization reaction, and we're putting it into an evaporating basin. Now, what we are going to do is we're going to put it underneath a Bunsen burner, add some heat. Now the water will evaporate into the atmosphere. And what will be left behind in the evaporating basin will be the salt. Okay? And water we know is neutral, but also the sodium chloride is neutral as well, the salt. Okay, it's not just the water. Okay, so what we've got, I asked you to write down this equation last lesson from the video. It's sodium hydroxide adding into hydrochloric acid gives us sodium chloride and water. Okay, as a simple equation is NaOH plus HCl gives you NaCl plus H2O. And this does not need balancing because the number of atoms on the left is equal to the number of atoms on the right. One sodium, one chlorine, one hydrogen, that gives you two hydrogens on the right, one oxygen, and we have got that as a balanced equation. Okay, now watch the video of this being done, this experiment of producing a salt being done as a demonstration, and then watch the video of producing salts as different types of salts. Okay, and then follow the extension task if you have time.